Hey, what's up guys? Rob here from Brevity. And in this video, we are going to be tackling the infamous linked list cycle problem. So if you're here after Vignesh pointed a gun at you and asked you to show up, you're at the right place. But if you have no idea what I'm talking about, go check out this video. It is a prerequisite and you need to watch it in order to understand this problem. Go ahead, I'll wait. Also, if you have no idea what a linked list is, watch this video over here. It's a 20-minute crash course on what linked lists are and how to use them. Okay, are you back? Let's continue. The first step to solving any problem is to carefully read the problem and understand it. So let's do just that. As we can see, we are now in LeetCode and the question is number 141, which is the linked list cycle. The given input is going to be the head of a linked list and we have to determine if the given linked list has a cycle in it or not. If a cycle does exist, we are going to return a value of true. Else, we are going to return a boolean value of false. Now what exactly is a cycle? They have given an explanation over here, but let's do it in a whiteboard tool to better understand. Here I have drawn two linked lists over here. The first one is where A points to B, B points to C, C points to D, and D points to null. In this case, there is no cycle present in the linked list as D is pointing to null. Now let's look at the second example. Over here, A is pointing to B, B is pointing to C, C is pointing to D, and D is pointing back to B. We can see that D is not pointing to null and instead it's pointing to another node in the very same linked list. This is what we call a loop. So now, if we are going to print the elements of the linked list, we are going to end up with an infinite loop. It's going to print A, B, C, D, B, C, D, B, C, D, B, C, D infinitely. This is what we mean by a cycle. Now that we have understood the problem, how would we implement an algorithm? So the next step is to think of an algorithm which can work for such a problem. And since we are in 2-pointer week, it's not going to be a big mystery. We're going to solve it using the 2-pointer technique, or more specifically, the fast and slow pointer approach. So how does it work? Imagine this. You're in a 100-meter race with Usain Bolt and the path is along a straight line. Once he overtakes you, is there any chance that he'll come up from behind you again? Definitely not. But let's say that instead of a straight track, we are now going to run a 1000-meter race in a circular track which is of 200 meters. This means that you'll have to run across the circular track 5 times in order to complete the race. Again, you're running with Usain Bolt. Now once he crosses you the first time, is it possible that again he might be able to overtake you from behind? It's possible, right? In race terms, it's called overlapping. And over here, you are the slow pointer and Usain Bolt is the fast pointer. The only way that he'll run into you again after meeting you the first time is possible only if the linked list has a cycle. In other words, a circle. Okay, now we're back in LeetCode and we're going to write the code to solve this problem. First, I'm going to take 2 pointers and make them point to head. These are called reference pointers. And I'm going to name them fast and slow. Now that I have created these two, I need to increment the slow pointer 1 step at a time and the fast pointer 2 steps at a time. This will be done with the help of a while loop. Now the while loop will obviously have a terminating condition. I'm going to write it down a bit later. First, let us write the steps which have to be followed. Inside the loop, we have to increment the slow pointer by 1 step. I'm going to say slow equals slow.next. And I have to increment the fast pointer by 2 steps. So there's nothing but saying fast equals fast.next. Now, after incrementing the slow pointer by 1 step and the fast pointer by 2 steps, let us check if slow equals fast. This is possible only if a loop is present in the cycle. So if at any point slow equals fast, then we are going to directly return true. Note that inside a while loop, if we are going to have a return statement, it's going to directly break control from the function and return true as the answer to this function. So now, what condition should we put inside the while loop? In this case, the terminating condition will be if the fast pointer has reached null. So if at any point if the fast pointer has reached null, then we can conclude that the linked list does not contain a cycle. So while fast not equal to null. And now outside we can return false, because if at any point the flow of control comes outside the while loop, then we can conclude that no loop is present inside the list, so we can return a value of false. So now let me submit this code and see if it works. That isn't what we expected, right? What is this null pointer exception? This is because we skipped step 2, which is checking for edge cases. So now let us go to step 3, which is the debugging phase. So let me go back to the whiteboard and show you something. This is the edge case, which we have to check for. Now, what if the linked list contains only one node? Inside our loop, we are attempting to increment the fast pointer by 2 steps, right? So when fast pointer is currently pointing over here, and we are attempting to increment it by 2 steps, where does it go? Fast.next is going to be null, as we can see. But what is fast.next.next? What is next of null? It doesn't exist. Hence the null pointer exception. So we need to figure out how to implement this edge case. At the same time, we can see that a similar problem will arise every time the linked list has an odd number of elements. Let us take this for example. Initially, fast is pointing to head, which is A. After the first iteration of the while loop, fast will now point to C. Now, in the next iteration, we'll be attempting to go to fast.next.next, which is again going to be next of null. And next of null doesn't exist. We'll be getting a null pointer exception. So, when we are over here, we also have to check that fast.next is not null. If fast.next is null, that will also be one of the terminating conditions for the while loop. So let us go back to our code and implement this edge case. So all I have to do is, I have to check while fast is not equal to null and fast.next not equal to null. Now that I've implemented this, let me try submitting again and seeing if it works. Yes, now we can see that the code is working successfully and we have gotten the output which we were expecting. Coming to the time and space complexities of this solution. The time complexity is going to be around O of n, where n is the number of nodes in the linked list. This is because inside this while loop, the maximum number of times where the fast pointer will be iterating is until it reaches null, which is going to be the length of the linked list. The other case is when the fast pointer meets the slow pointer, which is also going to be around O of n. So the time complexity for this solution is going to be O of n. The space complexity is going to be O of 1. This is because we are only declaring 2 pointer variables which are going to take constant space. So when we look at the space complexity, it's a really good solution because we're using 2-pointer approach. The other way to solve this problem will be using hash sets, which is what we discussed in one of the earlier videos where I spoke about Java STL. If we were to use a hash set solution over here, we are going to get a very similar time complexity, but the space complexity is again going to be O of n. So while using the 2-pointer technique, we can see that we are considerably saving a lot of space. Hence, it is a very important algorithm to learn, and this is one of the finest examples of its use case. That's it for today. Tomorrow, we'll be dropping the 3-sum problem, which is another interesting question which can be solved using the 2-pointer algorithm. If you haven't subscribed yet, do hit that subscribe button to make sure that you don't miss it. As always, this was Rob. You're watching Brevity. Thank you and goodbye.